I'm going to be walking through the final project for this course, and for this we're going to take a data set from Kaggle which contains custom information, things like date of birth, education, marital status, income, kids at home, things like that, and it's going to contain the data also contains information about how much products that they have bought, and the various types of product they bought, like wines, fruits, meat products, fish products, sweet products, and gold products. And the company has also run a few marketing campaigns, 5 to be exact, and whether or not each of those customers responded or accepted the offer, accepted each of those offers, and things like that, and things like whether they made their purchase through the company's websites, or through the catalog, or directly from the store, things like that. So that's the data. The goal, what we're trying to achieve, is to analyze this data to categorize the customers, and try to figure out how to market which product to each of those categories, right? So we want the best information. We want that information to in order to run our campaign, our ad campaigns and marketing campaigns effectively, right? So that's the idea. We want to categorize the customers to figure out how to best market to them. That's the goal, and that's what we're going to do. We're going to use k-means clustering and agglomerative or hierarchical clustering to achieve this. And we're just doing some exploratory data analysis over here, and here are all the columns. We can see that there are 358 duplicate values, and as far as missing values, nothing is missing values except for the income. 24 rows are missing over there. We're gonna take a look. We're gonna take care of that later on. And here's the plot distribution for all the numerical values. Right off the bat, we can see that the income has a huge outlier. Most of the data is over here, but there's 1 or 2 over here. Similar thing with the date of birth. Most of them are from the the oldest one is from the 1940s, but there does seem to be some values in the 1900s, early 1900s or late 1800s, things like that. And yeah, other than that, from the looks of it, it looks good. Let's look at it. Box plot, as expected, the income, there is an outlier. Someone probably added an extra 0 by mistake. And year of birth, there does seem to be some values in the late 1800s, right? We're gonna get rid of those. We're gonna get rid of the outliers. And here's a correlation matrix, which basically says how each feature correlates with the other features. For example, right, catalog purchases and meat products, so they're highly correlated. It would seem that most of the people who buy meat buy it from the catalog, right? Things like that. And over here, the 0.64, right, amount of wine and store purchases, it would seem that most of the people who buy wine buy from the store. And that's the correlation matrix. And we're gonna analyze the categorical features, the education and marital status. It has quite a few categories, each of them. And here's a bar graph about it. We don't want these many features. I would rather merge all these together into 2 categories, whether they're educated or not educated, right? And a similar thing here, right? We want to make sure we just want 2 categories here for the marital status, whether they're single or they have a partner, right? Together and married can be 1, single, divorced, the widow can be 1 category as single. Alone can be replaced as single, it's the same thing, and absurd and YOLO can be dropped. That's the idea over here. Here's a summary, basically, of what we saw earlier, what we saw so far. And here is where we are going to execute the plan, right? We're going to remove the outliers in date of birth and income. We're going to fix the marital status. We're going to drop the duplicates. We're going to fix the income, right? We're basically going to drop the null values, and over here we're going to merge some of the columns, some of the existing features. There are 5 ad campaigns that they have run. We're going to merge all of them together. We're going to merge all of them together into total accepted offers, into that one feature. And age group, we're going to merge it into three categories. Sorry, so 18 to 40, 40 to 60, 60 plus, and same thing with income: low, middle, high income. Has kids, kids at home, teens at home, we're going to combine them into a feature called has kids. And total spending, we're going to grab all the spending for all the various categories. We're going to combine them into total spending. We're not going to drop the columns. We're going to keep it, but we are going to add another column called total spending. Custom tenure, we're going to do a similar thing to the age, right? So we're gonna group them into new customers, mid customers, loyal customers. Marital status, similar thing as what we saw earlier, and education, right? We're going to say single, and single, widow, and divorced as single as 0. Together married is 1. Similar thing with the education part, right? PhD and master's is going to be education. The rest are going to be no graduation. And we're going to drop the index columns. We're going to encode it because when we're talking about clustering, we want to calculate the distance between each data point, and it's going to be hard to calculate the distance of string values, right? So we want to encode them into, we want to change them into numerical values, and that's what we're going to use a label encoder for. We're going to do it, and there's also an inverse transform here because we do want to transform it back for the final for the final step. And we're going to normalize the data using min-max scalar, right? Because we don't want any one feature to overshadow another feature just because their values are naturally larger. For example, income, right? It's natural to have an income of $150,000, but if we compare that to an age of just 35 or 40, that the income is really large. But we don't want that number to influence or overshadow the age just because it's a large number, right? So we're going to normalize it into using min-max scalar between 0 and 1, which is basically saying we're going to get a percentage of it. We're going to deal with percentages instead of actual values. That's the idea here. And here are the plot distributions again. If we see the shape of the plot is basically the same. The only thing that's changed is we have normalized the data. We're using percentage values instead of the actual values. So nothing is no one field is overshadowing another one. And we're going to use PCA to reduce dimensionality. And now we're going to train the model. As said earlier, we're going to try two clustering methods: k-means clustering, agglomerative clustering, and we're going to see which is better. Right? And we're going to test it using silhouette scores. And as far as silhouette scores are concerned, the closer the score is to, the closer to 1 is better, right? The closer the score is to 1, it's better. First, we're going to use the elbow visualizer, K elbow visualizer, to get the optimal K value, optimal number of customers, and we see that that's 5. Best K value is 5. And we're going to use a dendrogram to get the best, the optimal number of clusters for the agglomerative clustering, and we see that that's 2. And now we're going to apply it, and we're going to do some hyperparameter tuning. We're going to play around with linkage methods and metrics, distance metrics for the agglomerative clustering. We're going to use word complete average single for the linkage, and these 3 distance metrics, and we're going to see which is the best one. Again, we're going to use silhouette scores to compare, and we can see that the best linkage is average and the best distance metric is Euclidean, and we get a score of 0.394. And we're going to do a similar thing with k-means clustering, but the problem with that is there's not a lot of things to play around with. It's restrictive that way. So the only thing we can play around with is the init methods and k-means plus and random. And the best parameter seems to be k-means plus, which brings the silhouette score to 0.4091, which is better than the best agglomerative clustering. So going forward, we're going to use the k-means clustering model, right? And it makes sense too, right? If we look at the clustering, if we look at the scatter plot, it does look like a roughly spherical shape, which means that as far as k-means clusters are concerned, if the scatter plot is roughly shaped like a sphere, then k-means clustering would be the way to go. But if the scatter plot looks like a crescent, or if it's nested, then agglomerative would be the way to go. And since it's sort of roughly looks like a sphere, then k-means is the way to go, and that's what the silhouette scores proved as well, right? And and we have run this is the result of the k-means clustering. There are 5 categories or 5 clusters, and each cluster has this is the distribution of the number of customers per cluster, right? And here's the distribution of the spending. As we can see here, this is the total spending. As we can see here, cluster 1 are high spenders. Cluster 1 are our high spenders, followed by cluster 3, and followed by cluster 4, and then cluster 2 and cluster 0. Cluster 0 is probably our lowest spenders, right? And that's what we see over here. And this is the distribution graph for wines, for fruits, for meat products, fish products, and sweet products, and gold products. We can clearly see who the highest spenders are, who the lowest spenders are. We can clearly see that over here. And we're going to see here is another graph which basically gives the actual numbers. And we can see here, you know, for example, for cluster 0, for accepted offers, only 31 out of the 663 people as part of this cluster accepted offers from any of those campaigns, right? 632 people did not accept the offers. This is another way to gain some insight from here. And here's a summary table for everything. So cluster 0 is basically our low spenders, and they don't accept a lot of offers, probably because their income group is middle income, right? So they don't have a lot of money to spend anyway, things like that. And cluster 1, as we saw earlier, is our high spenders, right? And they have accepted a lot of offers as well, and probably because their income is high. 97% of them are high income people, right? So they do have a lot of money to spend, and they do spend it. They accept a lot of offers and things like that, and that's what we see from here, right? And that's what's mentioned over here. And each and recommendation for the company based on the customer behavior, right? So cluster 0, low spenders, not a lot of income, has, you know, 97% of them have kids. So then they should probably focus on family-oriented products that are on discounts or budget-friendly bundles, things like that, right? That's what we can. That's basically the insights we can get, the takeaways we can get from this particular cluster, from this particular model, from this particular data, right? And yeah, that brings us to the conclusion of the project. And I just want to say this was a fun project where I learned a lot about unsupervised machine learning methods, clustering methods like k-means and agglomerative clustering. And it was a nice learning experience for me. I learned a lot in the machine learning side of things, and also from the customer behavior side of things. It was always fascinating to know more about that. And yeah, I also learned more about which clustering method works in which scenarios and things like that, right? And the improvement that I would think of is basically there's not a lot we could play around with in terms of hyperparameter tuning for the k-means clustering. So what we could have potentially done is we could have created our own custom non-Euclidean distance metric like cosine, for example, and tested it out. We wouldn't know if it would make our model better, or it could also make our model worse. We don't know that yet, right? But it would be something. It would have been something. It would have been cool to play around with, to see how it would reflect on the model, right? To see the silhouette score, how it would perform. It would have been cool to see. And yeah, thank you for watching.